Hello friends, today we are going to learn two of the most useful concepts in basic electrical, the voltage divider rule and the current divider rule. If you understand these two rules, half of the numericals in basic electrical engineering becomes super easier. So let's begin. First we'll discuss that voltage divider rule. Voltage divider rule is used when resistors are connected in series. So series connection means that two or three resistors connected one after another like this. So this is a series connection. Now if we consider when the resistors are connected in series, the supply voltage gets divided according to their resistance values. If we connect one voltage source here, so this voltage will be divided in between these three resistors. So according to the values of these three resistances, larger resistance means larger share of voltages. If it is a voltage, if resistance is smaller, then a smaller share of voltages. If we consider that if this is the voltage source of this is V, this is R1, R2 and R3. So if we apply this voltage divider rule in this series circuit, so in that case we can consider V1 across that R1 and this is V2 across R2, and there is another voltage drop across R3, this is V3. So this is the three voltages. So we can find out these three voltages, that V1, V2 and V3 by using that voltage divider rule. If we want to write the formula for this, we can write, if I want to calculate that voltage across resistance R1, then we can write V1 is equal to that supply voltage into that resistance, this resistance R1 by total resistance. So that is by total resistance. So we can write that supply voltage means that is V into R1. So why R1? Because that is we are calculating V1, so that's why we are calculating this voltage across this resistance. So that's why that we'll write R1 by total resistance. So that will be R1 plus R2 plus R3. So this, by using this, we can find out the voltage across R1. Now similarly for R2 and R3 we can write R2. Similarly what we can write, R2 is equal to, voltage across R2 is equal to that V2 is equal to R2 by R1 plus R2 plus R3. Similarly for V3, that is the voltage across R3, we can write V3 is equal to R3 by total resistance R1 plus R2 plus R3. So this is the voltage divider rule, and this we apply to find out the series voltage drop across series resistances. Okay, now if we take an example, where three resistances connected with a voltage source. So this is the voltage source and three resistances are connected, 1, 2 and these three resistances are connected in series. So this is R1 is equal to 2 ohm, this is R2, that is 4 ohm, and this is R3, so that is 8 ohm, and the voltage of this voltage source is 24 volt. Now we need to find out the voltage drop across this V1, then this is V2 and V3. So we need to calculate these three voltages, V1, V2 and V3. So by applying voltage divider rule, we can easily find out the voltage V1, V2 and V3. So V1 is equal to the total voltage, that is 24, into that resistance we are finding out that voltage across this R1, so that resistance, that is 2, and the total resistance, that is 2 plus 4 plus 8. So this will be how much? The 24 into 2 by 14, this is 7, so that is 24 by 7 volt. Now V2 is equal to similarly 24 into 4 by 2 plus 4 plus 8, so that is 24 into 4 by 14. So that is, so we can write 7 48 by 7 volt. So similarly, so this voltage V3 is equal to 24 into 8 by 14. So that is 96 by 7 volt. So so this is the simple example of voltage divider rule. So by using this, we can easily find out that voltage across each resistance. So this is the complete explanation of voltage divider rule. This we can apply when we are solving big circuits. So let's understand that current divider rule. Voltage divider rule we apply in a series circuit, and current divider rule we apply in a parallel circuit. When the resistors are connected in parallel, if we see the connection, so in that case, that connection of the resistance will be like this. So this is the source. So this is the connection of parallel resistance. So in this condition, we will apply current divider rule to find out the different current values across each resistances. So by using that voltage divider rule, we can calculate the voltage drop across each resistance, and by using this current divider rule, we can find out the current across each resistance. Okay, if we draw a parallel circuit where this is the voltage source and 3 resistances are connected in parallel, 1, 2, we can draw here also. So this is the third resistance. So suppose this is V, R1, R2 and R3. So this is the total current which is when it will come here, then there will be 2 paths, so it will divide into 2. Okay, let just simplify small circuit to easily understand. So we are considering only 2 resistance where that current will be divided into 2. So that is, suppose this is I1 and this is I2. Now we need to find out these 2 currents, which is I1 is flowing through the resistance R1 and I2 is flowing through the resistance R2. So how can we find out these 2 current? By applying current divider rule. So what is current divider rule? Current divider rule is so that I1, so what you can say, I1 is equal to total current, or we can say the incoming current into that. When we are calculating this I1, so in that case we will consider opposite branch resistance, so that into opposite branch resistance by total resistance. So this is the formula of that current divider rule. So from this circuit, what we can write according to this I1, we can write I1 is equal to that incoming current is I into opposite branch resistance. So which one is the opposite branch resistance? So we are calculating I1. So which one is this? So this is the opposite branch. So what is the resistance? So that is R2 by total resistance. So that is R1 plus R2. So similarly, if when we will calculate I2, so in that case it will be just opposite. So this incoming current is same, that is I into, now it will be, so here it is I2, so that opposite branch is this is the opposite branch, so that's why resistance will be R2 by total resistance, that is R1 plus R2. So this is current divider rule. So by using this current divider rule, we can find out the branch currents. So by taking an example, we'll understand this. Just simple, we'll draw a simple circuit, so which is containing one source and 2 resistance are connected in parallel. So this is one resistance and this is the another resistance. So that value is given, suppose that this voltage source is 20 volt and this total incoming current, so that is 10. And if we consider these 2 resistances, suppose this resistance R1 value is given 5 and this R2 value is given 10, 5 ohm and 10 ohm. Now, so there is 2 currents. So this is I2 and this is I1. So we need to find out the value of this I1 and I2. So how to find out? By using current divider rule. So if we apply current divider rule in this branch, so in that case we can write I1 is equal to, so that 10 ampere, so that is the total incoming current, so that is 10 into opposite branch resistance, so that will be this R2, what is the value of R2? That is 10, and the total resistance, so that will be 10 plus 5, So if we calculate, then we'll get 100 by 15 ampere. So this is I1. Now if we calculate that I2, so in that case what we can write, so this is same 10, and now which one is the opposite? So this is the opposite branch, so that will be 5 by 10 plus 5. Now it will be 50 by 10 plus 5, so that is 15 ampere. So this is the two current which is flowing through these two branches. So by applying that current divider rule, we can easily find out parallel branch currents. So this is all about that voltage divider rule and current divider rule. If we know these two rules properly, then we can easily solve any types of problem in basic electrical. Thank you.